So we are going to go over the 3 different types that we've learned so far. Okay? So we learned the linear, we learned the quadratic, and we learned the exponential right now. Let's look at the difference. So the equation for the linear function was mx plus b, right? Where your m and b are numbers, remember that? M represents your slope, b represents your y-intercept. What was the equation for quadratic? Give me the standard form. ax squared. Okay, so I had to have that quadratic. I had to have that exponent too. For the exponential relation, it's going to be y equals a for your initial base to the power of x. So you see, for exponential, your base is going to be your x variable. In the table of value for your linear function, what was constant? First difference. How about for quadratic? What was constant in the table of value? Second difference. So when I did the subtraction, right? How about for exponential? The first ratio. The graph of linear function is going to be a straight line, yeah, or so it's going to be like this, right? Or it could be going down or whatever. It's just a straight line. For the quadratic, you guys said it's a parabola. So it's either up or down. For the exponential relation, it's going to be so I'm going to write the description for it. So one side is almost horizontal. While the other side grows or decays fast. No. Exponential. There's no name. It's not like parabola or straight line. It doesn't.
So I just put no name.
No name. So you'll see that you have a horizontal and then goes fast, right? Or it could be that it's going to decay fast and then you'll have a horizontal. Okay? So as long as one part of the equation, one part of the graph is horizontal, almost horizontal, and the other part is either decaying, so that means decreasing fast. So you see this is a fast decrease, and then slow decrease, or the slow increase and then a fast increase. Right? We saw that with like when we got to 256 or whatever folds, and then I went from 256 to 500, and then I went from 500 to 1,000. Right? We saw that fast increase. Okay? So decay means decrease. Now it's going to be linear, quadratic, or exponential. You're going to have to figure out, looking at the equation or at the graph or at the table of values, you're going to have to figure out which one of the 3 it is. So if you look at the first one, you have y equals negative 5 to the power of x. What do you think that is? Linear, quadratic, or exponential? What? Exponential. Why is it exponential? What's the exponent? Yeah. So it's exponential because your degree or your power is the variable. Exponent.
Variable what?
Exponent. Sorry, I have no room to fit all the whole word. How about the second one? And how do you know it's quadratic? Yeah. Degree 2. Right? Your exponent is 2, the highest exponent. How about the third one? Linear. Degree. Okay. Which one do you want us to do together? First one or second one?
Second.
All right. Why second one? Because the base is a half. Okay, so I have the x values, -2, -1, 0, 1, 2, and I have a half to the power of x, so that's my equation. Okay, so it's a half, oops, it's a half to the power of x. All right, so what's a half to the power of -2?
One. Half to the power of negative 2.
Is it 2 or 2? And we have to the negative is
4.
Remember when I have a negative exponent, what do I do? Flip. So if I flip this, it becomes 2 over 1 to the power of 2. What's 2 over 1 to the power of 2? 4. Love it. You guys give me a headache, I give you a headache back. Okay, now 1/2 to the power of -1. Yeah, so I have this, then I flip, so it becomes 2 over 1 to the power of 1, which is just 2. Okay, a half, let's see who knows the answer for this, to the power of 0. Look at you, before I even said it, you read my mind. Anything to the power of 0 is 1. How about a half to the power of 1? It's just a half. How about half to the power of 2? 1 over 4, right? You have a half to the power of 2. So the 2 get distributed for both. 1 to the power of 2 is 1. 2 to the power of 2 is 4. So that's a quarter. So let's look at the first ratio.
Sorry, Maya, the last one is half to the power of 2, right?
Yeah, so you have half to the power of 2, right? You remember that when I have power of 2 and I have division, I can distribute my power inside, right? So it's going to be 1 to the power of 2 over 2 to the power of 2. 1 to the power of 2 is just 1. 2 to the power of 2 is 4. How do I find my first ratio? divide my y values, right? So you see these y values, you're going to have to divide them. Okay, so I'm dividing 2 divided by 4. So what's 2 divided by 4? What's 2 divided by 4? So you have 2 chocolate bar and then 4 people. Each get a half. I wish we each get. When you're dividing the bottom divided by the top, right? No, it's y2 divided by y1. y2 divided by y1. Okay? How about the second ratio? What do I do? 1 divided by 2. So that's a half. Then for this one, it's a half divided by 1. What's a half divided by 1? Half. Okay. Let's see if you guys can do this. Eyes on me. So for the last one, I have a quarter, so 1 over 4, divided by 1 over 2. Stop. You two, stop. Okay. How can I simplify this? What do I do?
Divide 1 by 1 and 4 by 2.
I can't do that because I can't do that. This is not how it works. Instead of cross multiplying, what do you have to do first? I know what you're trying to say. If there was an equal sign, then yes, you can do that. And then at the end, it's going to work to be like the cross multiply, but there is a process that I need to do. Flip it, but first, what do I have to change? What do I have to change? To what? And then flip the second, right? So this is what happens with the division, right? When you have fraction divided by a fraction, you keep the first fraction, change your division to a multiplication, flip your second one. So that works out to be 2 times 1, which is 2, 4 times 1, which is 4. So that's 2 over 4, which ends up being 1/2. If you wanted to make your life simpler when it comes to this, find your answer, so the y values in decimal, and just do the decimal divided by the decimal. You might end up with a number that's not going to be like 100%, 0.5, 0.5, 0.5. But as long as they're close, then the ratio is close to constant, that's fine. So,
Sorry.
yeah.
So change your fraction to decimal, then do the...
Yes, but again, like in this case, for example, you might not get 100% exact ratio. You might get, let's say, instead of getting a ratio of 3, 3, 3, always 3, you might get like 2.999 or 2 point, you know what I mean? Because you're, for example, in this case, it's going to work out the same thing, but in the case of 1 over 3, what's 1 over 3 on the calculator? 0.333333, right? You're not going to actually do and write 0.333333 all the way, right? You might write it to 2 decimal place. So when it comes to finding your ratio might not end up being 3. It might end up being like 2.999, which is close to 3, right? So if you do the decimal instead of the fractions, you might not end up with exactly the same ratio, but at least round it. You round it. Okay? Did I know that my ratio is going to be a half? Did I know that my ratio is going to be a half? Yes, because my base is a half. I knew ahead of time that my ratio is going to be a half. Right? It's not a surprise for me. All right. These ones, yeah, you have to simplify. Right? So when you simplify, both of them are divisible by 2, right? So that gives me a half. Too much math? Your brain's hurting? Not yet? Okay, so since my ratio is constant, what do I say? Is it exponential or no? Okay, so determine whether the relationship is exponential. Give a reason for your answer. So yes, it is. First ratio is constant. Okay, I'm going to give you time to work on the first one. If you don't want to deal with fractions, you want to deal with decimal, that's fine. Do it with decimal. Okay? I'll leave you with this.